his like phone off so that his TA couldn't contact him, and he sort of lectured for 20 minutes while muted to all of these college students. And probably a metaphor in there for higher education or something. But
I know. Well, there was I was doing one session where my audio got cut off, and it takes a while for people. All right. Okay, I think I can hear you, so we're good. Can someone please confirm whether you can hear us or not? But from my testing, it seems like yes, I can hear Charles talking on this session. So if you guys can hear us, let us know. If you can't, then let us know too. All right. Welcome, everybody. We are back with Thursday live sessions. We had a bit of a break, but now we're back again. And with me, I have my good friend, Charles Mendelson, who's back for the third time. Today, he's going to be walking us through how to clean the messy data. Messy data is a reality. Like if you're dealing with data, data is going to be messy. So cleaning that data is critical before you make any business decisions. And that's what Charles is going to help us walk us through how to clean this messy data. With that, I am going to hand it over to Charles Mendelson, who is marketing data analyst at, hey, I forgot your company's name. Charles, you there?
Yes, I'm here. Yeah, so I'm a marketing data analyst at PitchBook Data.
PitchBook, yes. And he is marketing data analyst at PitchBook, and he's going to walk us through what he has been dealing with and how to go about cleaning it. So take it over, Charles.
Yeah, so one of the things that I think a lot of people, particularly in management, don't understand is how messy data often is. And that, you know, you can ask a really, really reasonable question that you expect your analysts to be able to answer quickly. And it just turns out that the data that comes into the system is so messy that it actually takes a long time to answer because you have to clean it up. And so one of the things I wanted to demonstrate was what I thought was a good representative example of really messy data that has a lot of sort of a lot of complexity to it that, you know, you wouldn't encounter this exact problem, but the idea is to outline the process to approach a problem like this, which will be very common. And the truth is, there isn't a data engineering team in the world that isn't, that isn't overworked right now. And so constantly having to give the answer, we have to wait a quarter for data engineering to get to it, is really not going to do you very well in your career, and it will substantially increase your value as an analyst to be able to take on these sort of light data engineering functions. So today we're going to walk through, I have two different data sources that both have problems with them. And we're going to walk through cleaning them up in Python, staging them in a local PostgreSQL server, and then bringing them together in a unified view that has all of the data in a way that we want that will actually let us analyze the data. So that's the plan for today. So this came out of a personal project of mine. I also really like history, and I just coincidentally found a history data set that had the prices of a grain market on the Rhine in Germany. If you're not super interested in that, that's fine. I promise you that the exercise of actually cleaning the data is super interesting. And I wanted to see if outbreaks of the plague influenced grain prices in this particular grain market, sort of a way of letting us look into the past. And I got to see some really cool things, but it took me a lot more work than I initially anticipated to get there. So you just give me 1 second. I am going to set everything up. So, and I'll be sharing my Jupyter notebook. The key thing about this is also all of the files that I am using in this demonstration are available on GitHub, which if they're not in the description right now, the repo will be in the description on the YouTube video. So if you guys actually want to go through and analyze what I'm doing in detail, this isn't my best code. I tried to write it in such a way that would be understandable to someone who is not a particularly proficient programmer. I am not the best programmer in the world, but I wanted to make something that was understandable and we could follow the logic. So, so here is my notebook. I'm using Visual Studio Code with the Jupyter Notebook plugin for it. It's not normally what I use. I actually normally use PyCharm, but PyCharm displays the cells right to left, so it's not as good for displaying for a presentation. So, so this is our goal. We've outlined our goal to investigate the impact of plague outbreaks. And so our objective is to clean and prepare the data in Python, load it into a PostgreSQL database to join it together and analyze it in Tableau. So these are the modules we need to do this. And I can briefly describe what each module does. So pandas is the go-to module for working with data in Python. It lets you organize things into data frames, which are, Python's way of handling tables. We need the JSON package because we have to actually save a file as JSON. We need the datetime package because we're going to be working with some datetime data. And then SQL, these two packages for SQL Alchemy are how we're going to write to our Postgres database. And then re is the regex module for Python. And regex stands for regular expressions, which are super useful to know if you ever have to redo anything with text data. Oh, and by the way, guys, if you have any questions, please let me know, and Neil will interrupt me. So
yeah, I just want to make a comment here. If you have any questions, feel free to write those questions in the comments. I will read those questions, interrupt Charles as he's going through to make sure he does not go all the way and then he has to come back. So there is a bit of delay by the time I read those questions or when you write those questions and I get them. So bear with that. But other than that, we're good. I want you guys to ask more questions. Otherwise, it's just going to be a lecture and you'll walk away with nothing. So
first thing we want to do, so we have our two data sets. The first one is about when plagues had outbreaks in different cities. So we're just going to display this particular one. And so what we can see is it's sort of a messy data set. It looks kind of like a dictionary of dictionaries. I'm actually going to copy one of these cells out, and so we can take a look at it. Let's just add a cell here. So we're just gonna, I'm gonna make this a markdown. We'll just comment it. So if we look at it here, we have a curly brace, we have this colon, and then we have each value in it. And it looks a bit like a Python dictionary, where a Python dictionary would be this. There would be key colon value. So it looks a lot like a Python dictionary, but it isn't a Python dictionary. So what we want to do is we want to make sure that we can actually turn it into something that Python can recognize. And actually, the file output that would be easiest would be turning it into a JSON file. So, and so as I said, it's a .txt, but the contents look like the JSON had a child with a Python dictionary. And it's very likely a Clojure hashed table. Clojure is a different programming language. It has some very specific scientific functions. And in Clojure, it actually functions very similarly to a dictionary or JSON file. So our pattern is colon key value with rows of data wrapped in curly braces and text wrapped in quotes. So in JSON, the pattern is key colon value. We looked at what the pattern would be in Python. And so we have to, so what we have to do is we have to move the colon and then wrap the key in quotes. And then we have to move the colon to be after the quotes. And I actually showed my process here because my original pass through the code, I didn't use regex. I actually just manually did a replacement operation to get everything where we wanted it to be. And the big challenge for that is that's a really clunky and messy way of writing it. I'm not the best at regex. So one of the first things I want to show you guys, because you guys know, I actually asked this as a question on Stack Overflow because I could not for the life of me get the regex to work. And I think I want to say in about 5 minutes, someone had just popped a reply here that actually had the exact regex set up for Python. So, so the first rule is you don't have to know everything. You just have to know enough to ask a good question on Stack Overflow. And if you do that, people are usually quite willing to help you out. You should search Stack Overflow first to make sure no one has answered that question. But so this is what this does. And then what we do is we run that. And now that has saved our formerly this format into a JSON file. And then we load that. And then we use pandas. Pandas, one of the file formats pandas can handle is JSON. So now, instead of having this whole mess of data here like this, we have something that looks a lot like a table. We have latitude, we have longitude, we have the name of the city, we have the data source. I'm less interested in that. And then we have the year. And then if we want, we can use the mask, something called masking in Python, where what we do is we create something called a mask. We take the column and we want it to be named. We want it to have the specific name, and that actually creates a Boolean data frame that just says whether it matches that, and that's true, true, false, false, you know. And then we use the pandas loc function, which is a filtering function, to essentially say, I only want the stuff that is true. So, and now this gives us a nice little list of every outbreak that happens in the city we are interested in. And the city Cologne is also called Cologne. It has 3 or 4 different names. And then what I've done is I have actually saved this whole thing to a CSV. So I don't, you know, if I ever pick up this project later, I don't have to run through those previous steps. I have this in a format that I know is universally usable and that I can use. So having staged my file, I am now going to load it into a SQL database, where this is where we bring in PsychoPG2 and SQL Alchemy. And then to save to a Postgres database, you have to actually have your credentials. This is not the best security practices. There are ways of masking what your credentials are and loading them from a path variable. That's overkill for the purposes of this demonstration. So it's just my local Postgres SQL server. So the password is password and the username is Postgres, and this is the local host. And then once again, you would never have those as your credentials in a production environment. And then here we are driving the engine, and then we are going to save it in this table called outbreaks using the engine into a schema called plague demo. And now it is there. And what I can show you is I am now in my SQL IDE, and we're just going to select star from, what is this? This is demo database.plague demo.outbreaks. And we now successfully queried our SQL database. And we have all of that data that was in that nasty text file now in a SQL database where it can be joined to things as we want it to be. So now we are moving on to the second part of our data. That was a relatively simple problem. It was essentially a regex operation on text and then getting it into a database. But relatively simple does not mean fast if you've never seen it before. So now we're just going to do a quick inspection of our data. I've preset this to look at a particularly problematic year. So if we look, we sort of have this, it's set up as year, month, week. And what we've done is, and then there's a product for it. And what this does, and if we look, we're pretty good through June. And then we have a break in our data. Which goes from June until September, there's no data. And that is going to be a problem if we ever want to map or graph our time series data, because it's just going to skip it over, so you won't see your 0 values. Then the other problem that we have is that it actually violates the one record, one row principle. Because, for example, we have year 1540, January, week 1, and then we have barley. And then down here, we have the same thing for oats. Ideally, these should either be separate tables or in the same row. And I'm going to sort of show you how to turn them into separate tables and then put them in a new row. By the way, Neil, do you have any questions? Have any questions come up?
No, no questions so far.
Okay, so I have this as a CSV. So I'm loading it from my CSV. And then I want to make sure all of our months are the same length. So I have this function here that just says, if a month is less than 2, I want it to be, I just want you to prefix a 0 in front of it if it has less than 2 digits in it. And then we're just creating something called a key, because I actually want there to be a key on this, because right now there isn't a good key. When we look in here, we have our index spot, but we don't have a unique key for each combination of year, month, and week. So my solution to that was to essentially, we're just joining them as strings. And actually, a key is okay to have as a string because it's not a numerical value. When we get into data typing, you can't really add 2 keys together or subtract 2 keys and really get a meaningful result. So it's okay if they're strings. So we're going to run that. And so now we have our nice little key value here that is exactly what we want. So one of the other big problems I had to solve in this presentation was the fact that
I have a question here.
Yep.
From Roberto. Roberto Perez asks, it will be a course of these. So I think that question for me, Roberto, there are pieces to this, not entirely this course. That's what he's talking about here. You have Tableau, SQL, and Python. That's what he's referring to. So these bits and pieces courses are there. You just put those together to what he's showing.
Yeah.
How much SQL? Yeah, go ahead.
The idea is to sort of show a holistic workflow, because you sort of almost never use these tools in isolation. The different tools serve different functions. So I primarily use Python for data cleanup, and then SQL for data staging and the more complicated joining operations, because SQL is just a faster way of handling a lot of that. So if you think about the goal is Python, the goal is to get it into SQL, and then the goal in SQL is to get it ready for your analysis software and staging it in a way that your analysis software, can really effectively use. Yeah.
So as he said, there are Python is to get that data in SQL. Once it's in SQL, you have to write your SQL scripts and queries. So in many cases, you'll have a data in flat file that can directly be imported into SQL as well without using Python or anything. So it's just a way of loading whichever you're comfortable with. The next question Roberto has is how much SQL I need to handle, or is there another question? I don't get this, like how much SQL? Well, I'll let Charles talk about how much SQL knowledge. But Roberto, whatever SQL is needed, that there is already a course in Optizen Academy that walks you through different scenarios. And that SQL covers pretty much 90+% of the SQL that you'll ever need. And maybe there is a little bit SQL that you need with the complex scenario, but it has all the syntax that you will need is there. Now it's a matter of putting those together for your particular use case.
So, and I will just add that like knowing SQL and pursuing a career in analytics, it's really not optional. It's the lingua franca of data. I can't, only at the smallest startups. I've only ever worked at one company, and it was a super small startup with about 20 people, that SQL wasn't a daily part of what I do, just because when you get anything remotely close to scale, you just need a way of managing the data, and SQL is the primary way of doing that.
Yeah. I mean, that's one skill that I say master that skill. You need to go deeper, practice it. And, different use cases, different scenarios will come up where you will test your limits of how much you know and what you know, but get the fundamentals right, practice it on regular basis, so that when those scenarios come, you actually have the fundamentals down. And now it's a matter of putting those together, different pieces together to come up with your solution.
So yeah, and then the other thing is, yes, sometimes you do get a flat file you can directly load into SQL, but usually that's also a manual process. So even if you're getting a flat file regularly, you can automate that on a regular basis using Python in different ways.
Yep.
So and I didn't demo it here just because it was too complicated to do it. But if we go back, you actually, we have missing time series.
One thing I'm going to ask you is, Charles, from your experience learning from Python and getting to here, how much experience do you think a person needs in Python? Basic Python to get this done? Do you need to go deeper? I think that's what people are asking. A lot of people are in digital marketing analytics roles, right? They are looking at the data in tools like Google Analytics, or if they have in Google Data Studio, Tableau, etc. They usually use those tools, but writing these scripts is something that they haven't traditionally done. How much experience or how much Python do they need to know?
So I was fortunately, like, at my first position where I needed to learn Python, I was given a decent amount of time to learn how to do it. Mm-hmm. And I would say I started learning Python in, I think, December, and I deployed my first script into production at the end of February. There is sort of a handful of things that you need to know before you can really start doing this. And I actually didn't use a lot of them in this. Mm-hmm. It's also possible to go fairly deep into certain specific aspects of Python. So one of them is the pandas library. And I would say that that's got about a similar learning curve to Excel. If you know the basics of Python and you know the pandas library, it's about as, you can learn pandas with about the same amount of difficulty as you can with Excel, maybe a little more.
Okay. So, but to do something like this, where you can take a flat file, convert it into the JSON format and load it.
Yeah, I mean, it's a question of how long you're willing to take to do it too, because that's the other thing. And I will say this one took me an embarrassing amount of time to actually solve all of these problems, because I think I slotted it for an afternoon, and it ended up being more. But basically, I mean, so if we go back to this one, we can solve this problem without the regex. We can actually use this original thing, in which I basically just take each instance and do a string replace method.
Yeah. Mm-hmm.
That's not advanced use of Python. I don't think I'm demonstrating anything in here that is particularly advanced or complicated. These are all fairly normal Python operations. I'm probably going to get a little bit more into the pandas stuff, because there's just some stuff that it requires a little bit more advanced. But this isn't anything that, if you put aside an hour a day for a month or two, that you couldn't do yourself. It might take a little while to do initially, but the other thing about Python is, once you start solving problems with it, you can solve it. When you encounter similar problems, you actually already have code written that you can then just edit.
Exactly. Yeah. Yep.
So copy and paste is the best friend of any Python developer. And I actually am now keeping it's essentially a graph database of my code, so that I actually can easily reference anything I've already done. I can look up, so I can try to solve similar problems more efficiently.
Okay, cool. So I'm going to make one more comment here, Roberto. If any of these things you require within Optizen membership, you will have access to a bunch of this knowledge. So if you ever do get stuck with, hey, how do I do this kind of stuff? You will have that kind of support. So I just want to call that out.
So returning back to where we were. So if you remember, we actually have missing time series data in this. And then the other problem that we have is, actually there will be some weeks where barley would have been sold. That is, there's a record for barley, but there's no record for something else. So there isn't actually a natural leftmost position on the table. And when I say leftmost, my philosophy on building tables is I build them with something called left to right, in which I have my most complete data on the left, and then I left join things onto that and sort of build it out that way. So the idea is, and that's actually a very common way of building a sales and marketing funnel too, where your leftmost table will be the top of your funnel. And as things go further and further through the funnel, by left joining onto that, you're actually naturally sort of actually creating your funnel shape doing that. So in this particular instance, and I actually I decided not to do it because the code to solve this particular problem was probably more advanced than we want to get into. So, but I created a master list of every week that happened through the whole series of the data. And what made it particularly complicated was there was actually a calendar change during this. So there was the shift from the Julian to the Gregorian calendar, which dropped 12 days, which creates some headaches when dealing with that. So, and if people have an interest, I can do another short talk on how exactly I did that.
Sure.
But the moral of the story is we have a good leftmost position. I very creatively named it leftmost, which is our master week list. And it is the same as our index here. So, and we can actually display leftmost. So we can see that it's actually just a series of weeks with a year, month, and a year, and going into there. So, and that's a way of thinking about solving a problem is, okay, I have all of these different data sets. I don't have a natural point to start. How can I start thinking about what is in all of them that I then need to create? And having null values in a row is fine. It's more valuable to know that when that record happened in this time series, actually, we didn't have anything happen. That's an incredibly valuable piece of information, and it's sort of a next level of analysis.
Yeah, actually, you mentioned something very critical, and this is an important point, is rather than thinking about like, okay, how do I write this or that, you have to start thinking about what's the problem you're trying to solve. I think most of the people just jump into, I need to do something here. Like first formulate what you need to do, because even if you do not know, I mean, this is the way I look at it. I was actually demonstrating this to somebody who was saying, I need to learn jQuery for everything because Google Tag Manager can do this and that. I'm like, no, you don't need to know everything. You need to know fundamentals. Give me a problem right there on the phone. I was like, give me the problem, what you're trying to do. Gave me a problem. I said, okay, I do not know that level of JavaScript or jQuery or whatever. I'm going to go to Google. I know what you're trying to solve here. I'll go find bits and pieces because first I need to do this, then I need to do this, then I need to do this. That's the thinking I have. It doesn't matter what language I'm using, what code I'm using. I went and got the pieces and got the code done. So that's the way I think. A lot of people get too bogged down into, I need to know everything. I'm like, no, you don't need everything. You just need to know how to put the pieces together, what questions to ask, and then get it going and refine as you go.
So much of programming in an analytics environment is just like using the Google tool, finding someone's code who solved a problem that was kind of like yours.
Yeah.
Copying, pasting it, running it, figuring out why it didn't run, and then just making all of the small changes. The core of the problem has probably already been solved. And a lot of this is around building the literacy to then be able to adapt someone else's solution to what you've done.
Correct. Exactly.
So I will do my brief little spiel on like what are the core tenets of the analytics stack, and that is a scripting language, which would be Python or R. I don't think it matters too much which one you learn. I've never known a company that will say, oh, R, I'm not going to hire you, or Python. Yeah. It's really like even at my company, our job posts just say a scripting language, and that lets you do things like this. Then you need SQL. SQL's the basis of everything. Everything flows through a SQL server. It just does. Then you need to know spreadsheets, and you need to know a way of displaying your data. And if you know the basics of those, it shouldn't really matter too much if someone's using a slightly different tool. You'll be able to adapt. It's the thinking that really matters.
It's the thinking that matters. Yeah. And that is most of the battle. Actually, I was planning on putting this out. There is a knowledge and there is the mindset that comes with that knowledge. Like how much mindset you have to take and put the pieces together. You don't need detailed knowledge about everything. You need to know what problem you're trying to solve, how you will solve. So that analytical thinking, that putting the pieces together, that's what you need.
Yep. And so this is probably going to be the most complex piece of what we're doing. And I'm not going to explain it in a huge amount of detail. I'm just going to summarize, give an overall summary of what it's doing. So you can start to think like, this is what you need to do. You can figure out how, as long as you know what to do. So we have four products in there. We have barley, oats, rye, and wheat. And our main table currently violates the principle of single row of data for a single record. And so what I really want to do is break this into 4 different tables. So, and that's just what this code is doing. It's just saying, it just does this and it creates a different table for each one of these things, creatively named barley, oats, rye, and wheat. Now, don't get too creative with your names on any of this stuff. You want someone to look at it and go, okay, that's the data frame with the barley data in it. You don't want someone guessing like, you don't want people like temp variable 62. That no one knows what that means. So, and then here I created a function. A function is just sort of a repeatable process to do. And what it does is it takes a data frame as an argument and a type of grain as an argument, which we have. And it does a bunch of different operations on them. The first thing it does is, because I want to be able to differentiate which table a column comes from, we just essentially append the name of the grain to the column name. This will come in a lot of handy later when we get to SQL and we have to start joining the tables together. So we don't have like 4 columns named price. We want barley price and oats price. This one I'm sort of on the fence about. I did it in Python. I think doing it over again, I would do it in SQL. There's a different type of currency that's used in part of the table, and I want to create a harmonized value in the table so that I don't have to do complex lookups. I could have also done this in SQL, and looking back on it, that's probably what I would have done. On the theory that it's it's an operation that can easily be handled in SQL. So leverage SQL for the things that can be easily handled there. But the basic idea is we say, hey, if it's this particular type of thing, just multiply our price by 4, and that creates our harmonized thing. That's all this is doing. And if anyone has any more specific questions I can help answer, I'm happy to. I'm just trying not to also get too bogged down in the details and sort of have people super dissect the code.
I think, we just need the concept of what you're doing, that helps, because there are several ways of handling stuff and don't want to go too deep into the code.
So, and then we have these, and honestly, I probably need to chunk this out into different functions too. That's a different story. But the basic idea is we then have the price. We want to take the price of our grain, and then we want to take how much we sold just to actually get the total amount sold. Once again, this is doable in SQL. And then we have, this is to actually get the delta values for all of them. So if we want to see how much of a week over week shift there is, that didn't turn out to be as useful in the final analysis, but that also tells you something. Sometimes you think something is going to be useful and you code it, and then you get it into production, and it just turns out not to be as helpful as you thought it would. So, and then down here, we're actually just calling our function and creating our four little databases, or our 4 little tables to do this. And then the last thing we want to do is, I probably need to start running some of this code so I don't hit an error. So the last thing we want to do is, remember how we created that natural leftmost point? We want to now take all of our separate product tables and put them on that so that we actually have all of our null values where they're supposed to be. And then lastly, once again, we want to run this through our, we want to put this in our SQL server. So I'm going to do that. So now we can get to our SQL server. I'm just going to go ahead and refresh this. One of the features of this is it'll give me IntelliSense and autocomplete if it actually knows what's in it. So we're just going to take a quick look. Demo dot. We'll just look at barley. So this is our barley table, and this is behaving as we would expect. See, we can even see that, for example, in on the third week of March in 1532, there was no barley. And that is something that we would have missed if we just used our flat file and loaded it into the table. It would be very hard to see how we would actually find that out. So we're now going to go quickly through this. Once again, there are better ways of writing this query to be more performant. This isn't a very large data set, but I also wanted to keep it to do it in such a way that the logic would be very easy to understand. Mm-hmm. So we're using a SQL function that I'm very fond of called a common table expression, or a CTE. Mm-hmm. CTEs, if you know what a subquery is, a CTE is an alternative way of using a subquery or doing a subquery that I think is actually more readable. It lets you structure your code and structure your thoughts as well. So that's one of the reasons why I like CTEs. Subqueries can end up very tangled and interconnected with one another, and it can be very hard to tease out what's doing what. Whereas a CTE is sort of is just a more chunked out way of doing it. Mm-hmm. And so what we're doing is we're taking all of our columns from each of our grain tables. I could have done select star, but that's generally not a good best practice. You should specify all of your columns that you're using. And so these four are all just go there. And then what I also want to do, because I want to identify what years have a plague year in them, I want to grab the name and year from our outbreak data set where the name is the city that we want. And just to show you guys how that works, we can highlight it and then we can run just the CTE. And so this is our nice little year. This tells us that. So now we go into the main part of our query, and we want several things in our query. We want the index, we want the year, we want the month, and we want the week. And because we did that leftmost operation, I only have to grab that once from one of the tables, and I went alphabetically and I chose barley as the first one. So that's why we grabbed those. And then this is a case statement. It's sort of a complicated if statement that lets you test multiple conditions. And this was just so we can look at seasonal data too. We want to know, when are the prime times for people to, buy and sell grain. And then we want to grab the currency. We want to grab the number of, so here we're actually grabbing our specific columns. And then here we are grabbing our total value sold. And so we're going down here. And then the last thing we want is we want to add up all of the different sub products to get the actual total value for the whole market. And once again, this is relatively easily done in SQL. It's just, take your thing and add them together. SQL does that really easily. And then the last thing we have is we have a case statement for when our plague year is not null. We want to say it's true. And then if it is null, it's false. This could have been done as an if statement. I just prefer the syntax on case statements. And then we have that as end as plague year. And then we have our joins. So once again, we're building from left to right. We left join oats onto barley, where the year, month, week equals the year, month, week, and we do the same thing. And then the last thing we do is we have our plague data where the year equals the year. And then here we have a nice thing where if we go here, we can actually see that we have all of these. And then if we scroll all the way down, we can see that we get to the year 1540, which is our first plague year. And we have it marked as, we have it flagged as plague year in here. And we can get more complicated if we want, like we could add other historical events. Those we probably have to hard code, but it's not super hard to do. And that's sort of a good overall way of setting this up. This is now a data source that we can give to our visualization software to really allow us to get into the nitty-gritty of the analysis. So, but this is all of the work that it took to get it to there. And that's sort of the data is a lot like an iceberg. So you have people who are, like your customers, your stakeholders, they see the top of the iceberg. They don't see the 80 to 90% of the data that it took to get them the graph they wanted to look at or the analysis they were looking at. So, and I think I'm happy to leave it open to some questions. If you have any questions, Anil, if there's anything you want me to look at, we probably could do things like we could round this, but that's basically what I have for this week.
Cool. Yeah, no more questions. This is great. And you have a part 2 as well, right?
Yeah, I will then, I was thinking I would, maybe not next week, but probably in the next couple of weeks, we would do actually showing, okay, so we've done all of this. Let's look at it in Tableau and figure out what all of this means, because looking at several thousand rows of tabular data is hard to get any meaning out of it. So we start to sort of, let's guess at a hypothesis and let's see what we can do with it.
That's cool. Yeah, I think let's do that. I don't have any questions. Please type in if you have any questions, but that'll be interesting. Particularly, Tableau, looking at that's your data visualization tool. So you'll get to visualize this data, and then you can see all the pieces, how they come together. Python, SQL, Tableau, and then analysis on top of that. So,
yeah. And I mean, I can talk briefly about other data use cases for Python where I run into this one at work, where we actually have a few different databases that don't naturally connect to each other. And so
we can do that. But yeah, we can do another session on that.
Sure.
Altogether different session. So I think this is great. Any questions? All right. If there are no questions, then this will be the end of the presentation. If you do have any questions, those who will be watching replay, please put your questions here. Charles and I will be watching those questions and you'll get your answers. And anything that you feel like we should dig deeper into, any topic, then leave that as a comment as well. All right. Anything else, Charles, you want to add before we end the stream?
No, I just want to thank you for the mentorship you've given me over the years. You've been meeting you is genuinely life-changing for my life and my career. So
cool.
I'm just
happy to hear that. You're welcome. Okay, that's it then. Thank you, guys. I'll see you in the next live session. I do not have anything planned for next week, but things do change during the week. So stay tuned and watch the emails from me. And I'll see you the during the next live session. Bye. Thanks, Charles. Thank you very much for your time.
Thank you.
Yeah. Bye.